Okay, good morning, everybody. Welcome to Math 096. Hope we had a wonderful break and we're back ready to get going here in this new semester. Like I mentioned, we've got 4 different handouts and we'll talk about each of them briefly right now. First one I want to talk about is the key prerequisite skills. It's the 1-page sheet of paper. Come on in. So that key prerequisite skills is just as it sounds. It's a list of skills that I'm assuming you have coming in here, or even if it's a little bit rusty, you can kind of shake off some of that rust and get back into the groove and answer most of those questions without too much difficulty. If you have a lot of difficulty on that sheet, see me. Maybe I can point you in the right direction and give you some resources that will help you shake off some of that rust. Or if it happens that maybe you're in a course that's a level above where you belong, that key prerequisite sheet might be the first warning sign. In any event, it's a conversation we can have. I'm not going to collect it, but it is something that I encourage you to do between now and the next time we meet on Tuesday, okay? So do let me know if you have any troubles, significant troubles on that key prerequisite sheet. There is an answer key on the back of that sheet. Okay, the next document I want to talk about is the syllabus. So it looks kind of like this. And so my contact info is up there at the top. My name is Ian. Please call me by my first name. You'll find my work email address there and my office phone number and also my cell phone number, which is my way of saying it's okay to call me on my cell phone number. Sometimes I have students who will flounder around on one problem for like an hour. And I don't think that's a good use of your time. And perhaps with a 2-minute phone call, I can give you the little push that you need to get you to be able to finish that problem and maybe the rest of the problems if it's just one thing missing, sort of in a homework set. So feel free to call. That's why I put my number there. I do have office hours, but I'm available many hours other than what's listed there. So if you want to meet with me, just let me know and we will meet. There's lots of good information in this syllabus. We're not going to go through it all right now, except for one piece of information, and that's having to do with your textbook. So our official textbook is Intermediate Algebra for College Students by Robert Blitzer. They are currently in the 7th edition of this textbook. The current edition of most textbooks is ridiculously expensive, but if you go back to the previous edition, it's often much, much less expensive. In an effort to save my students money, I have made it so that you can use either the 7th edition, the current one, or the 6th edition. That's the older one. Okay. So either edition is fine, and we're not going to use my math lab. I've decided to opt out of that as well as another money-saving effort. So just any copy of the textbook from the bookstore or someplace online or somewhere else is okay. All right, any questions about textbook? If you do end up buying the book online and it takes a few days or maybe a week for the book to come in, there is a copy of the book in Math Studio and there's a copy of the book in reserve in the library, okay? So you can use those copies while you're waiting for your book to come in. Okay, like I said, lots of other stuff in the syllabus, but that's all we're going to talk about together here. You'll read it over the weekend and you can let me know if you have any questions. Okay, next document I want to take a look at is this one. It says homework packet at the top. So because I'm allowing 2 different editions of the textbook, I need to give 2 different sets of homework assignments. Here they are. So if you use the 6th edition, you are going to do the assignments in the first column. 7th edition, doing the assignments in the second column. The first page is the bulk of the homework, but there are some problems that are supplemental, and that's what the rest of the pages are. You don't need to worry about it, but you'll see references to them. So for example, right here in number 4, see supplemental problems for homework number 4, which is a few pages after this one in this little packet here, okay? All right, so homework assignments are all here. My decision to drop my math lab, it's okay if you don't know what that is. It's just a website that you can use. Yeah. My decision to drop my math lab happened after I printed the big packet that we haven't looked at yet. So you're going to see references to my math lab in the big packet. Ignore those. This is your homework right here. Right? Homework assignments are always right there. Yes. I think that it's cheaper to buy the books without my math lab. That's why I switched. Okay. All right. Yes. Yeah, totally fine. Yeah, totally fine. Okay. So the last thing that we're going to talk about, which is where we will spend most of our time today and every day in our class, is the big old packet. So it looks like this on the front. And we'll start with our daily summary. In this lesson, we review solving equations and graphing. So that's the plan for here. We're going to skip over this paragraph, and I'm actually going to leave you guys to work with your neighbors for a little bit of time right here. I'm going to put some check marks next to the things that I want you to do with your neighbors, the people at your table. You're going to read number 2 and fill in those 4 blanks. You're going to read number 3. I'm going to highlight that everything in this math problem you're about to do has to do with the equation y equals x plus 4. And as you work through number 3, you're doing A and B and C and finally D. So pretty much everything on this page, but start by reading number 2 and filling in those blanks. Go ahead. Summarize. So we've got our 4 points from the table. We plot our 4 points in the graph, and then we notice, I don't know if we're surprised or not, but what kind of a shape appears to connect those dots is a straight line, right? And so we draw a straight line, use a straight edge if you have it, something like that. Although I only hit one of my points, but that's okay. Straight edge would be better. And so we will talk a bunch about lines. In fact, maybe the first third of this semester is about lines, but I will just highlight kind of a preview of coming attractions, an equation that I think all of us have seen before, y equals mx plus b, sure looks an awful lot like y equals x plus 4, right? And so maybe not so surprising that it is a line. We will talk about the mx plus b thing. Yes? Yes. Good question. Did everybody hear the question about like style and graphs, and do you need to label X and Y on the axes, and do you need to put arrows? I'm particular about some things and not other things, and I don't have like just a rule of thumb that I can share. But in particular, these questions, I don't need you to label X's and Y's. I don't need you to put arrows on the axes. There is a common way to lose points on a question like this, and that's instead of drawing that line, to instead draw. You guys see that? Maybe I need to pick a different color there. What's wrong with that green line? It's supposed to go forever, right? Now, so in theory, you know, like maybe at some point you were told you have to put lines, okay, or arrows. I don't need you to put the arrows. I don't need you to put the arrows. But if you draw this thing in green here, that's your way of saying this line definitely stops, and it definitely does not stop. And so make sure that your graphs extend all the way through the axes. That's good enough for me. All right. Okay, let's keep on trucking here. Oh, and then the last thing is about the quadrants. Where is quadrant 1? Top right. Okay, so 1 there. For some reason, we use Roman numerals on the quadrants. I don't know why. And then which way do we go? Counterclockwise. Okay, so 2 up here, 3 down here, and then 4 is there, which means that our line passes through 1, 2, and 3. Good. All right, any questions on this page? Okay, next page, and we're going to solve our first equation. Uh-oh. Uh-oh. Off. Okay, on page 2, we've got an equation that is definitely a lot harder than the equations on page 3. If you can solve this equation, you're in good shape. Here's the equation. 1/2 x equals 5/3 times the quantity x minus 65. We've got 2 techniques to solve this equation, one of which I hope you believe at the end of this is a whole heck of a lot easier than the other. But first, we're going to do the hard way so that we really appreciate why doing it the other way is better, okay? So here's one technique. A lot of students feel like when they see this kind of pattern with a number being multiplied by a couple of terms in parentheses, they should distribute, right? And it's totally fine to distribute. You're not obligated to distribute, but it's legal. So let's follow what happens when we distribute. So first, the 5/3 times x is 5/3 x. 5/3 times 65 is now the first like fraction thing we've had to do this semester. You guys remember how to multiply fractions, right? Multiply straight across, top times top, bottom times bottom. So we're doing 5 times 65 on top, 3 times 1 on the bottom. Apparently that's 325 over 3, okay? All right, the next thing we recognize is that there are x's on both sides of this equation. That is a fundamental issue we need to resolve. We're going to move all the x's over to one side. I'm going to choose the left-hand side of this equation. How do I move this 5/3 x from the right side to the left side? As we subtract 5/3 x from both sides, right? And so we can see that right here. There's a minus 5/3 x on the left-hand side, and the 5/3 x on the right-hand side has vanished. It canceled out. That's why we subtracted 5/3 x. Okay, but now we've got another fundamental issue. It's right here. 1/2 x minus 5/3 x. It looks intimidating. I'm going to show you an example that hopefully is not intimidating at all. And if we understand how to do this example, we should be able to apply the same principle to the complicated one with the fractions. How much is 7x minus 4x? It's 3x, right? 7x minus 4x is 3x. How did we get that 3? We just did 7 minus 4, and then we tacked the x on at the end, right? That's how we subtract like terms. And so we play the same game down here. Apparently what that means we need to do is 1/2 minus 5/3. 1/2 minus 5/3, just like 7 minus 4. And then whatever we get here, we're going to tack an x on at the end, yes? Okay, how do we subtract fractions? Common denominator. We've got a 2 and a 3. What is the lowest common denominator? 6. So we multiply the 2 by what number to build the 6? 3. So if we multiply the bottom of a fraction by 3, we had better multiply the top of the fraction by 3 as well. So that fraction becomes 3/6. And then the other fraction, multiply this 3 by what to build the 6? Multiply that by a 2. So we better multiply the top by the same 2. So upstairs we now have 10. So 3/6 minus 10/6 is a better form of that subtraction problem. And so then we subtract upstairs. 3 minus 10 is -7. Downstairs is 6. So -7/6 is the final result from doing that fraction arithmetic, right? But remember, we're supposed to tack an x on at the end. So -7/6 x is the result when we subtract those two terms. Good? Okay. All right, almost there. We're trying to solve for x. That -7/6 is the only thing standing in our way. So one technique would be to divide both sides by that -7/6. Yeah? Dividing by fractions is kind of messy. There's a better alternative, which will get us to the answer in a little bit more of an efficient way. Instead of dividing by -7/6, we could multiply by -6/7. What's the fancy word for the flipping over a fraction? Reciprocal, multiplying by the reciprocal. So we're going to multiply both sides here by -6/7. Even if it's not clear why that's a good thing to do, as long as we do it to both sides, we're following our algebra rules, so it's legal. And then why it's a good thing to do is that, let's see, 7 and 7 cancel, and 6 and 6 cancel, and that negative times that negative makes a positive. And so all that remains on the left-hand side is 1x, which is the goal, right? We want 1x. So the last thing here that we need to do is be able to multiply -325 by -6/7. Again, how do we multiply fractions? Just go straight across, right? Straight across, no lowest common denominator. So multiplying straight across gives you, I don't know, let's actually write it down here. 6 times that, 18, I think that's 1950 over 21, 3 times 7 on the bottom. And that actually reduces. It's not obvious to me that it reduces, but it does. And if we don't reduce it, we'll lose a point at the end of a problem. So a better way, before we multiply straight across in these fractions, is to reduce first. And so what do you see that you can reduce in the first fractions here? Which ones go away? Yeah, that 6 and that 3, right, have a common factor. So this 6 becomes a 2, and that 3 becomes a 1. Turns out that's the only thing we can reduce, and so multiplying across in the reduced fractions will give us our final simplified answer. So that 325 times that 2, that's the 650. 1 times 7, that's the 7. Negative times negative is a positive. So x equals 650/7 is our final reduced answer. If you thought your math teacher was going to take it easy on you in the first day of the semester, you were wrong. Okay, I said there's two ways to solve this equation. That was the hard way. I'm not saying I don't want you to be able to do all of the fraction arithmetic that we did, but there is a much easier way to solve this problem. Here it is. The difficulty in the solution that we just covered is that there are fractions floating around all over the place. And so anytime you have an equation with fractions in it, there's a way to get rid of those fractions right off the bat. And that's what we're going to do here in method 2. We're going to multiply both sides by a magical number. And that magical number is the one that's going to get rid of all the denominators, and it is the lowest common denominator. So it's still 2 and 3. The lowest common denominator is still 6, so we are going to multiply both sides by 6. So that is written right here. Whole thing was just copied, and then in the front on both sides you can see 6 times. Okay, let's start reducing. 6 and 2 reduce. I mean, it's just 6 times a half, right? But that just becomes 3. And then the 6 times the 5/3. Again, we're going to reduce. Did I do that right? Yeah, okay. And then 6 and 3 becomes a 2 on top of a 1, yes? And so on the left, the right-hand side, all we have here is a 2 times 5 sitting in the front, which is 10. And that's it. And what has disappeared? The fractions. They're all gone. And solving this is going to be straightforward. Definitely much easier than what we did above, where we had the fractions all the way until the end. One common error that students can make is they think, okay, if I multiplied over here by 6, it's not just a matter of multiplying this 5/3 by 6, but they also bring the 6 in here. But that's not right. You have only 1 6 to play with. It would be like if I said, you know, how much is 2 times 3? And we're going to just multiply that by 4 for some reason. It would be like multiplying the 4 by the 2 and by the 3. This is not a distributive example, right? This is just you're multiplying 3 things and you can multiply them in whatever order you want. So the 6 that we chose to put in here, it's not distributing. You just have a single 6 to play with. We choose to smush it in with this fraction, just like you could choose to do the 4 times 2 first, right? Okay, so let's finish this one here. What should we do on the right-hand side? So here we are going to distribute, but the pain has disappeared because we got rid of the fractions. So 10x minus 650. Same issue as above. We've got x's on both sides. How do we fix that? Well, you could add the 650. I'm going to focus on moving all the x's to the left-hand side. So subtract the 10x. And how many x's do you have over there? After you subtract is negative 7x. Everybody see that? Subtract 10x from both sides. And then finally, how do we solve for x? Divide by negative 7. So negative 650 divided by negative 7, and it becomes positive because of the 2 negatives. Yeah, I mean, we have to end up with a fraction because that's the answer to the problem. But doing it this way gets rid of all the fraction stuff throughout. Okay. All right, I think that is good. So here is the basic flow of our course, and we'll get into this throughout the semester. But generally speaking, I'm going to come up here. I'm going to lead something called the demo. That is what we just finished. Then the bulk of the period is going to be you guys working with your neighbors on this thing called the activities. Okay. So you're going to get as far as you can on these activities here. Again, you've got lots of resources in this room as you work through them. You have each other. You have an answer key to all of these activities. If you just go a couple of pages down the road, you will find it. And you have me, and the very easy way to call me over is to just raise that flag, and I will be there in a jiff, okay? In the meantime, I'm just going to walk around. But if everybody at your table is stuck, you raise the flag, and I will get to you very soon. If it happens that you finish all of the activities, so that means this page and this page is actually the easiest page today, but it's going to be tricky until we understand what we're doing. I'm happy to help there. But if it happens that you finish all of the activities in any given day, you will turn the page and find this thing called even more practice. And it says up here that these problems are optional. You're going to do them if you finish the activities early, or if you just want more practice outside of class. You've got this resource of problems, okay? But my expectation is that you're going to be working on math the whole time that you are here in this room with me. And if you're playing with your cell phone and texting, then you're not working on math. So I humbly request that we ignore the distraction of the cell phone and put it in, not even in the pocket where it might vibrate and distract you, but put it in your bag so you don't have to worry about it. And my expectation is that you will finish all of these activity problems at some point, even if it doesn't happen during official class time, you finish them outside of class, okay? All right, so we're gonna work as far as we can here. At some point I will stop you and we'll do something new. So let's get going with your neighbors here.